A triangular piece of wood has vertices or corners A minus 1, 1, B 7 minus 3 and C 1, 3. Part 1, verify that the triangle is right angled at the point C. Part 2, this triangular piece of wood is to fit exactly into a circular container. Find the equation of the circle. So part 1, verify that the triangle is right angled at the point C, which is 1, 3. The easiest way to verify that AC and BC are perpendicular is to use its slopes. So the slope of AC, so we're going to label the A x1 y1 and the C x2 y2 and substitute into our slope formula, which is y2 minus y1 divided by x2 minus x1. And we end up with 3 minus 1 divided by 1 plus 1, which is 1. So the slope of AC is 1. Next we're going to get the slope of BC. So we label our point B x1 y1 and our point C x2 y2, and again we substitute into the slope formula, y2 minus y1 divided by x2 minus x1. We end up with minus 3 divided by 7 minus 1, which gives us minus 1. As m1 multiplied by m2 equals 1 multiplied by minus 1, which gives us minus 1, AC and BC are perpendicular, and the triangle is therefore right angled at the point C. So perpendicular slopes multiplied together will always give us minus 1. Part 2. This triangular piece of wood is to fit exactly into a circular container. Find the equation of the circle. So here we have a circle, and we have the diameter AB and the point C, which is a right angle. And because this triangle fits perfectly into the circle, and because we know that this is a right angle, we found that in part 1, we know that this therefore must be the diameter. So since we know the two endpoints of the diameter, we can find the midpoint between them, which will be the center of the circle, and then with that we can find the distance between the center and one of the points on the circle, which will give us the radius. And using the center of the circle and the radius of the circle, we can then find the equation of the circle. So from geometry, the circle that contains all three vertices of a right angled triangle has the hypotenuse as a diameter. So the hypotenuse of a right angled triangle must be the diameter. So to get the center, we're going to find the midpoint between A and B. So we're going to label our points x1, y1, x2, y2 and use the midpoint formula, which is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So we end up with minus 1 plus 7 divided by 2, comma, 1 minus 3 divided by 2, which gives us 3 minus 1. So the center of our circle is 3 minus 1. Next, to get the radius, we're going to get the distance between the center of our circle, which is 3 minus 1, and one of the points on the circle. I'm going to go with B, 7 minus 3. But you could have used A or you could have used C. So again, I'm going to label my points that I'm using as x1, y1, x2, y2 and substitute into the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we end up getting the square root of 7 minus 3 squared plus minus 3 plus 1 squared, which gives us root 20. So the radius is root 20. So we have the center, 3 minus 1, we have the radius, root 20, so we just use the equation of a circle formula. So basically we just swap the signs for x and y values. So we end up with x minus 3 squared plus y plus 1 squared is equal to 20. So this is the equation of our circle.